This is pre-calc, section 5.2, exponential functions. Here's an important fact. For any real number, a greater than 0 and a not equal to 1, a to the b is equal to a to the c if and only if b equals c. We're going to need that fact to be able to solve some of these exponential equations in a minute. And another thing we need to solve these exponential equations is this major exponent law. When you raise a power to a power, you multiply the exponent. So x to the a raised to the b power is x, keep the base, and multiply the exponents. A times b is ab. So x squared raised to the fifth power, keep the base of x, multiply 2 times 5 is 10. More likely what you'll see in these equations is something like this, and what you need to be careful of course, we're keeping the base, multiply 4 times this outside exponent. Since that outside exponent is a binomial, you've got to distribute. So 4 times x is 4x, 4 times 5 is 20. So we will use both of those facts in solving these equations. So these are exponential equations, and one way to solve an exponential equation is to get a common base. It's very easy to get a common base here if you recognize that 4 squared equals 16. So I can write this as 4 squared. This stays 4 to the x minus 3. And now we're going to use that property that we started with on the video. The bases are the same. Therefore, all I have to deal with is the exponents. If the bases are the same and the expressions are the same, then the exponents must be the same. And this is all I have to set equal to 2, add 3 to both sides, and I get 5. These are very checkable. You can check with your calculator or by hand. If you put 5 in here for x, 5 minus 3 is 2, 4 squared is 16. If you do use your calculator to check these, and you do 5 stow as x, and you come back and do 4 to the, you need parentheses around this x minus 3, because x minus 3 is a binomial. This one, I have a common base already of e, so e to the 6x minus 1 equals e to the 4x. Where did 4x come from? Using our exponent law, keep the base and multiply the exponents. Now I have these two equal expressions. If the expressions are equal and the bases are equal, all we have to deal with would be the exponents. So I have this very simple equation, 6x minus 1 equals 4x. Subtract 6x from both sides, gives us negative 2x over here. Divide both sides by negative 2, and x equals 1/2. So this is one, maybe you don't want to solve by hand, but you could do 1/2 stow as x, and then be sure though, you type this in as e to the parentheses 6x minus 1, and you hit enter and leave that on your screen, and then you can type in e to the 4th in parentheses raised to the x power and hit enter, and those two values should be the same. To do this one, you have to do a little bit of thinking. There is no power that goes on 9 to make 27, so I have to think about what base I could use for both sides. Well, 27 can be written as 3 cubed. So this is 3 cubed, all raised to the 5x. 9 can be written as 3 squared, all raised to the x plus 1. Notice I had to put the 3 to the third and 3 to the second in parentheses. Now I use my exponent law, keep the base and multiply the exponents. Over here, keep the base and multiply the exponents, keeping in mind we need to distribute, so this becomes 3 to the 2x plus 2. Our expressions are equal, our bases are equal, so all we have to do is set the exponents equal and solve. Subtract 2x from both sides, and we have 13x equals 2. Divide both sides by 13, and x is 2/13. Obviously, you're not going to solve this one on your own by hand, but this is one that you could use the calculator to check. Stow x is 2/13. Type in 2 to the, and you do need parentheses around that. Even though that is not a binomial, you do need parentheses around that. And then do 9 to the parentheses x plus 1, and both of those will be the same on your calculator. But this is important that you would put that 5x in parentheses. When you look over here, the 5 over 2, 8 over 125, I know that 2 to the third power gives me 8. I know 5 to the third power gives me 125, but this is upside down, so we have to do a little bit of thinking here. Our base can be 5/2. So we're going to keep this as 5/2 to the x. And if I want this to be a 5/2 as a base, I have to think about, for the 5 to go to the bottom and 2 to go to the top, I need a negative exponent. And the power that would go on 5/2 would be a -3. Let's go over that again. The reason it's negative is the fraction flipped upside down. The reason it's 3 is because 5 cubed is 125, 2 cubed is 8. Now we have both of these being equal to each other. I don't have to do a whole lot of work because the bases are the same. All I have is x equals -3, and that is my answer. So the reason we had the negative exponent is because this base that we had over here needed to flip upside down. All right, we got a couple little word problems dealing with compound interest. There are 2 different formulas for compound interest. One of those formulas is what I call the long form. It is for compounding n times per year, like semi-annually, quarterly, monthly, or daily. You use the longer formula. For continuous compounding, you use what's called the PERT formula. It's a lot shorter. Both of these have A, and A stands for the final amount. P stands for the word principal, which is the money you start with. R is your rate, and that has to be expressed as a decimal. So if you get something like 6%, it needs to be written as the decimal, 0.06. And T is your time in years. Now these numbers down here should be memorized. You probably know this already. Semi-annually, n equals 2. That means that you are compounding twice a year. Quarterly is 4, like 4 quarters in a dollar. Monthly is 12 because there's 12 months in a year. And daily is 365 because there's 365 days in a year. So let's do some problems here. Here's the formulas, and you do need to memorize these. I just put them on the page to make it easier for us here. So find the accumulated value, rounded to the nearest cent, of an investment of $25,000 for 7 years at an interest rate of 5% if the money is A, compounded semi-annually. Compounded semi-annually means n equals 2. Investment of $25,000 is P, 7 years is T, a rate of 5% is 0.05 equal to the R. So we're using this formula right here. So A equals P, which is 25,000, parentheses, 1 plus 0.05 over 2, because it's semi-annually, raised to the, now there's another place you have to be careful about parentheses, raised to the n times t. N is 2, t is 7. You need to have that in parentheses. Now, when it's this small, instead of doing parentheses of 2 times 7, you could just do to the 14th, because you could do that in your head. But you'll see on the next one, you're not going to do that part in your head. This now is just a straight calculator problem. You enter it exactly as you see it, including those parentheses. And what we get is 35,324 and 35 cents. So we want to round it off to the nearest cent. This next one is the same formula. Now the reason you know you needed this longer formula for these 2 problems is because of the words semi-annually and daily. The only time you get to use the PERT formula is when you see the word continuously. So daily is going to be the same setup here, 25,000, parentheses, 1 plus 0.05 over 365 for daily, because there are 365 days in a year, to the parentheses 365 times 7. See, like the 2 times 7 you could have done to the 14th in your head. Well, you're not going to do 365 times 7 in your head, but you can enter this on your calculator as you see it, and we get $35,475.84. Notice, the more often you compound it, the more money you make. This was $35,003. This is $35,004. Now, compounded continuously says I get to use the PERT formula, which is just a little bit shorter. So it's still the 25,000. E is E. And when you do E to the caret comes up and the parentheses come up automatically. The rate is still 5%, so that's 0.05 times T, which is 7 years. Enter this as you see it. You should remember to get E to come up on the calculator. You hit second ln, and we get $35,476.69. So compounding continuously gets you the most money.